It's a little after 9, and there's nobody here yet, and that's perfectly fine. I know not everybody who takes an online class can meet during specific days and times. So I'm going to record this. Um, I think it will be really helpful for you to watch before you take the test. Um, that way you can come and view it just whenever you have time. So I did get a couple of email questions. And I've got a couple different screens open here. So I'm going to write and take notes on this screen. And then I also have MyLabs Plus open and a list of questions that one of your classmates asked me to answer. So these are all from the homework, which it's a good idea to study your homework because all of the questions on the test will come from your homework. The questions are computer generated, so they might just change the numbers in the question, but the directions and description and everything will stay exactly the same. So that's why at the beginning of the semester I told you to keep really good notes. Even on your homework problems, keep really good notes of the problems that you're doing and exactly how you're doing them. That way you could have them out when you're taking the test. So this first question is from homework number 1, and it's number 25. And it is definitely one of the trickier questions. It says a suspension bridge has 2 main towers of equal height. A visitor on a tour ship approaching the bridge estimates that the angle of elevation to one of the towers is 26 degrees. After sailing 382 feet closer, he estimates the angle of elevation to the same tower to be 56 degrees. Approximate the height of a tower. So what we have here in this problem are 2 different right triangles, and we're trying to find the vertical side that those 2 right triangles share. So I'm going to copy this problem over onto my my notebook sheet and go through how to work it out. But this is definitely one of the trickier ones. I also want to note here under the answer box, it says round to the nearest integer as needed. So always be really careful about anything you see under the answer box. They're going to give you directions on how exactly they want the answer entered. And even if your answer is equivalent, but it's not in the correct format, MyLabs Plus is liable to count it wrong. Now, after everybody finishes their test, I'm going to go through and I will give you credit if I know you understand how to work the problem. So you would only lose just a very tiny bit for not following directions. But I am able to go in and see what you entered and what the correct answer was supposed to be. And if you have an equivalent answer, you rounded wrong or you entered it wrong, I can go in and get back partial credit for all of those things. So I'm going to go over to my white sheet now, which is Microsoft OneNote, and copy down this triangle and show you how to work it out. So we've got 26 degrees, 56 degrees, 382 feet. And I've got a stylus here that's supposed to be helping me draw, and it is not helping right now. I'm going to grab my other one and see if my other one's going to work. There we go. Sorry about that. So this one was 26 degrees. The larger one was 56, and the length is 382. Now the 382 is only this side. It does not include this side here. It does not include that. So we're told that we want to calculate the height. We have no idea what the hypotenuse for either of those triangles are. We know a piece of that adjacent side, but we don't know this other one. So I'm going to tell you right now, we're going to have to use, based on where these angles are drawn and what we already know and what we're trying to solve for, we're going to be using the tangent function because we're trying to solve for the opposite side. And in one of the cases, we know part of the adjacent side, and so we're going to label the other piece with a variable. And since we have two triangles, we're going to come up with two equations, which is appropriate. If you remember from algebra class, if you've got two unknowns, in order to solve, you're going to need two equations in order to do it. Otherwise, you're not going to be able to solve. So for the yellow triangle, the big outside triangle, we've got an angle of 26. So the tangent of 26 is equal to opposite, which is the height, over adjacent, which is this whole entire side right here, the whole entire bottom side, which is x plus 382. Now for the smaller triangle, which includes the 56 degrees, we've also got an angle and the opposite and adjacent sides labeled. So tan of 56 is opposite, which is h, over adjacent, which is x. And let me tell you right now, I've got two small children, and you will most likely hear them in the background, so I apologize for that. We are interested in solving for h. Right now, though, the easiest thing to do, I believe, is to solve each of these equations for h and then use one to replace the other. So if I want to solve this equation for h, I need h all by itself, so I'm going to multiply both sides by x plus 382. And then down here, I just need to multiply by x. Now, this same exact h is equal to both of those things. So h is x plus 382 times tan of 26. And h is also x times tan of 56. And those are the exact same two h's. So really what we can do is we can set the expressions with the x's equal to each other. So I can say x plus 382 tan 26, and notice I have my x plus 382 in parentheses because it has two terms, and the tan 26 is going to have to be distributed to both of them. That's equal to x tan 56. Now, even though I'm not asked to solve for x, I think this is the easiest way to do this problem to avoid having to work with fractions and stuff. So I'm going to go ahead and distribute here. That way I can get my terms that have x's together. So I have x tan 26 plus 382 tan 26 equals x tan 56. Now in order to solve for x, I need every term with an x to be combined. So I'm going to take this entire term from the left and move it over to the right. Now those x's do not cancel. The tangent parts of them really just have number values, and when we figure out the number values for tan 56 and tan 26, they're going to actually serve as coefficients on the x. So in my calculator, I am going to ask what tan 56 minus tan 26 is, because that's actually how many x's I'm going to have when I combine. So we get 382 tan 26 equals, And I'm going to go to my calculator and figure out that value. Make sure your calculator is in degree mode. About halfway through the chapter, we learned about radians, and you probably did some problems where you had to put your calculator in radian mode. For the test, be really careful about what mode your calculator is in. Really, the only way to be 100% certain of which mode it should be in is if your angle has a degree symbol on it, then it's degrees. If you don't see the degree symbol, then the angle that you're given is in radians. So in my calculator, I'm asking what tan of 56 minus tan of 26 is. And that's going to be my coefficient on my x. So I've got 0.9948 approximately. And to solve for x, I just have to divide that number over. Now what I'm going to do, in order to not round anything, I'm going to, in my calculator, ask what, so algebraically, technically we need to divide over the 9948, but I'm not going to round that because I've got the full value of that decimal on my calculator screen right now. So what I'm going to type in is 382 tan 26 divided by, and I'm going to tell the calculator to recall the previous answer. That way I'm not typing in a rounded number. And the way that you recall the previous answer on your screen is second and then the negative button, which is down near the enter and the decimal point button. If you look above the negative button, it says ANS, which is previous answer. So I'm telling my calculator to use that full previous answer rather than me rounding it. Because some of these problems, they do not want you to do any rounding until the very end. So when I do that, I get 187.28 for x. We were actually told to solve for h. So if you look back up at the top, we did have a formula that had x and h in it. We know that tan 56 is equal to h over x. And when I solved that for h, I got h equals x tan 56. So I can take my x value and multiply it by 56. So h equals x tan 56. And again, I'm not going to round this number. I'm going to tell my calculator to recall the previous answer. So I'm going to, in my calculator, say tan of 56 times, and then second negative again, to tell it to recall the previous answer. So I still have rounded nothing. My calculator is always using the full value of the previous answer rather than me rounding multiple steps along the way. If you round several steps before your answer, every time you do that, it throws your final answer off further and further and further. And MyLabs Plus is really sensitive to those rounding mistakes, and it will tell you wrong even if you're just off by a tiny bit. So when I do this, I get h is 277.6575797. Now that's the full decimal on my screen, but remember it wanted us to round to the nearest whole number. So because my tenths position is greater than or equal to 5, I'm going to round that up to 278. So the height for our tower on the bridge there is 278, and I believe it was feet. Yep, we were in feet. It's 278. And you can also see the person that sent these questions, they had gotten it right, but I know sometimes when you do the help me solve it button, it walks you through how to do the problem, but you still don't really understand what's going on, and you certainly might not be confident in being able to reproduce that problem on a test. So 278 is correct. The second question on here, and let me go back and label this because I'm going to post these notes as well, and I want you to be able to figure out where these problems came from. So this was homework number 1. Number 25. Now the next one we're going to look at is also from homework number 1, and it's also an application problem, but this one's number 29. It says a window washer on a ladder looks at a nearby building 107 feet away, noting that the angle of elevation to the top of the building is 18.7 degrees and the angle of depression to the bottom of the building is 7.1 degrees. How tall is the nearby building? And the directions on this one again are round the final answer to the nearest foot as needed. Round all intermediate values to the nearest integer as needed. So in this one, they are saying round along the way. And that probably has to do with what kind of answers they're going to accept. It's probably a little bit different based on whether you round it along the way or whether you just round it at the end. So again, we've got 2 right triangles here. Unlike the last one where one was inside the other, here we've got, they're still sharing a side, but one is above and one is below. So I'm going to go and draw this. This is number 29. And still on homework number 1. And this length here, they said, is 107 feet. And we're given those 2 angles separately. One of them is an angle of elevation and the other is an angle of depression. So the angle of elevation is 18.7. Angle of depression is 7.1. So 18.7 and 7.1. So now the height of the building is this entire side over here, which we're actually going to break up into 2 pieces and solve for them separately, and then at the end add them back together. So we could think of this as like the opposite side in the top triangle and the opposite side in the bottom triangle, and the full height of the building is those 2 added together. So again, just like our last problem, we've got an angle. We're trying to solve for the opposite side, and we know the adjacent side. So this side right here is adjacent for both of those triangles. Adjacent means the side is used to help create that angle. And then opposite is directly across the triangle. And notice that this side over here does not touch that 18.7 angle at all. And this side here does not touch the 7.1 angle at all. So that's what makes them opposite sides. But the 107 touches both of them and is used to create both of them. So that's the adjacent side. So because we're working with opposite and adjacent, we're going to set up tangent. So the tangent of 18.7 degrees is opposite over adjacent. And we're going to solve that equation for x. That's going to be part of our building height. And then for the lower triangle, tangent of 7.1 degrees is y over 107. And we're going to solve that one for y, and it will give us the other part of our height. So in both of these problems, all we need to do is multiply that 107 over to get our variable isolated. So I want to know what 107 tan 18.7 and 107 tan 7.1 add to be, because that will equal x and y, and we said adding them together will give us the full height. So I'm just going to type this entire thing in my calculator, 107 tan 18.7 plus 107 tan 7.1. Again, make sure your calculator is in degree mode. I see a degree symbol on those angles, and that's really the only thing that tells me for certain that my angles are degrees and not radians. So I've got 107 tan of 18.7 plus 107 tan of 7.1. and my calculator says that those add up to 49.545, on and on and on. And we're told to round this to the nearest integer, the nearest whole number. So because my tenths position is 5 or greater, I round it up to 50. And you can see on the sheet it is 50. All right, the next question, the next few questions are from homework number 2. And they're not application problems. They have to do with understanding positive and negative angles and very large angles and reference angles. So 6.3, number 43, this is homework number 2. It says question 43, and you know what? I labeled those other two wrong because I actually should have used the number up here, the 29 and the 30. That's what's going to match on your homework when you go back to review it. So I'm going to go and change those to 29 and 30. Those are the last two problems in homework number 1. So this one is actually 29 in your homework. And this one is 30 in your homework. Those other numbers that I was referencing actually tell you how these problems match up with the problems in the book. So there was a problem at the end of section. Let me show you. Because it says 6.2.29, that means if you look in section 6.2 of your textbook, at the end of that section, the exercises, this problem matches up with number 29 at the back of the book, or at the end of section 6.2. And the problem before that matches up with, it says 6.2.25. That means at the end of section 2 in chapter 6, the practice exercises, there should be one just like this, number 25. So this number here matches up with your textbook, but I should be probably referencing this number here because that's what you're going to see in MyLabs Plus. All right, so on to homework number 2. It says find the reference angle and the exact function value if they exist for tan of negative 300. So we are now in homework number 2. And this is question number 8 from your homework. And it gives us tan of negative 300 degrees. It wants to know the reference angle as well as the exact function value if it exists. So negative 300, negative angles mean that we're going clockwise around our axes. So every time you go one axis, it's 90 degrees. So this is negative 90. This is negative 180. This is negative 270. So to go from negative 270 to negative 300, I've got to go 30 more. So this angle all the way around right here is negative 300 degrees. Reference angle actually is referring to the distance to the closest piece of the x-axis. And when I say closest piece, that means if we're in quadrant 1 or 4, the positive x-axis is closer. If we're in quadrant 2 or 3, the negative x-axis is closer. So if we're at negative 300, the reference angle is always going to be inside of our reference triangle. The reference triangle always connects us to the x-axis. They're asking us what that angle is. Now, that angle would take us, if you follow the curve, it would take us the rest of the way around the circle. So we've already traveled 300 degrees. Once all the way around is 360, which means our reference angle has to be 60 degrees. Now, there's another way to figure this out. The other way just involves memorizing a bunch of formulas. I really like this description better because it gives the reference angle meaning. The reference angle is always the distance to the closest piece of the x-axis. And it's always positive, and it's always less than 90. So you should never be more than 90 degrees away from the x-axis at any time around this circle. The other way to do this is first by making your angle positive, by finding a coterminal angle. It will be easier to identify what quadrant your angle is in if it's between 0 and 360. So the other way to do this, where you just memorize a bunch of steps and a bunch of formulas, but it doesn't really give you an explanation as to why, is you take your angle, and because it's negative, we're going to add 360 to it. Now, luckily, that's all we have to do on this problem. Sometimes it's not. Based on the quadrant you're in, you might then have to do another calculation. Sorry, I keep moving this around. You might have to do another calculation to get to the x-axis. So theta sub r means reference angle. And I'm going to use that notation in this little chart. So if you're in quadrant 1, the angle that you have is the reference angle. They're the same. If you're in quadrant 2, to get your reference angle, you would have to go the rest of the way to 180 to get to the closest piece of the x-axis. Your angle would be a little bit less than 180. So to get the reference angle, what we would do is we would do 180 minus your angle. So say we were at 150 degrees, which is in quadrant 2. The reference angle is the distance from our angle to the closest piece of the x-axis. When you're in quadrant 2 or 3, the closest piece of the x-axis is the negative x-axis, which has a measure of 180. So if our angle is 150, the closest piece of the x-axis is 180, we are 30 degrees away. So 180 minus 150 is 30 degrees. Now in quadrant 3, you again would connect back up to 180, but the difference is in quadrant 3, your angle is bigger. So you would do your angle minus 180 because a reference angle always has to be positive. And in order to connect back to the x-axis, we're actually reducing the size of our angle to get to 180. So that's why your angle is first, 180 is second. In quadrant 4, you're almost all the way around the plane. And the closest piece of the x-axis would be to connect your angle the rest of the way to 360. So you've already done all of this, and the reference angle would connect it the rest of the way. So it's 360 minus your angle. So you always want to start off with something between 0 and 360. That way you can identify what quadrant it's in. And then based on what quadrant, we have this calculation to get us to the closest piece of the x-axis. But either way, we end up with a reference angle of 60 degrees here. And now we're also asked, what is the exact trig value? So tan of negative 300 when we drew that, we saw that it was in quadrant 1. And in quadrant 1, tangent is positive, and negative 300 has a reference angle of 60. So tan of negative 300 is the same exact thing as tan of 60. You can always change your angle to the reference angle. You just need to be careful on whether it should be positive or negative in front based on what quadrant you're working in. And since we're in quadrant 1, everything's a positive in quadrant 1. So we are going to do positive tan of 60. And you can use a unit circle to figure that value out. It's not going to tell you the exact value because unit circles have just sines and cosines on them. But if you look on your unit circle at 60 degrees, which is up here, that point on the unit circle is going to be negative, or excuse me, not negative. It's going to be 1/2 and radical 3/2. Now these values are really important because they tell us cosine of that angle and sine of that angle. And we can get tangent with those numbers because tangent is equal to sine over cosine. And on our unit circle, we have both of them. So we need to take the sine value, which is the second value, and divide it by the cosine value, which is the first value. So we're going to do radical 3/2 divided by 1/2. And instead of dividing by a fraction, you should flip and multiply instead. And we'll see that those 2's cancel out, and our denominator is just a 1, and you don't ever have to write a denominator of 1 because dividing by 1 doesn't do anything. All we're left with when we simplify this is radical 3. And you can't do this in your calculator because radical 3 is an irrational number, and your calculator will only give you the decimal back. It won't give you the exact answer back. So we have to know how to use our unit circle and use these values from the unit circle to figure everything else out. So the unit circle gives us cosine and sine. We can use that to create tangent. And if we know sine, cosine, and tangent, we could easily get cosecant, secant, and cotangent because they are just the flips of those original 3. So even though our unit circle only has 2 values on them, we could use them to actually generate all of the values. So you see it does say that reference angle is 60 and the exact value is radical 3. Now the next problem is problem number 9, and it's asking for the same exact thing. It says find the reference angle and the exact function value if they exist for sine of 7200. And this was problem number 9. So we're being asked the exact same thing. Now this angle is so gigantic. What that angle means is we're doing multiple trips around before we eventually stop at our angle. Every single time we go around, it's 360 degrees. Every single time we go around. So what we need to do is figure out how many times we can take 360 out of this, because all those extra loops around the plane don't change the trig values. So I'm going to divide by 360. This is going to tell me the whole number of times I can take 360 out of 7200. And it tells me I can take it out 20 times. There are 20 extra loops around my graph. Now, my number in the calculator came out to be a whole number. If it came out to be a decimal, you would only use the whole portion of it because we only want to take off whole loops around the plane. Those full loops around the plane don't change the trig values because once I get back to the x-axis, the same exact numbers start over and over and over again. Same exact numbers. So this is just like finding a coterminal angle, but I'm using a little shortcut here because 360 is going to be subtracted so many times. I'm going to try to subtract them all at once. So 360 times 20 is 7,200. So 7,200 minus 7,200 is 0. That means the reference angle here is 0. After I took off 20 full loops around the plane, I'm left with nothing. That means we're going to circle around the plane 20 times and then stop at 0. So the reference angle is 0. And we want to know the sine of 0. Without even memorizing, if you understand what this unit circle is, all of these points on the unit circle are actual xy coordinates that you would see in the xy plane. So the unit circle always has a radius of 1. 0 degrees is here on the positive x-axis. This point right here has got an x value of 1 because it has a radius of 1, and it's got a y value of 0 because we're not going up or down any. We're staying right on the x-axis. And remember, that first one is cosine and the second one is sine. So sine of 0 equals 0 because it's the second coordinate on our unit circle of the points on the unit circle. I'm going to pause real quick and just go back to the Google Hangout page just to see if anybody's here or has posted any questions. And I am still all alone, which is perfectly fine. Let me see. Let me see what the next question is. Exact the same thing again. Question number 10. Find the reference angle and the exact function value for cosine of 600. So I'm glad this one came up because we can't subtract 360 a whole number of times. Or excuse me, it doesn't come out a whole number of times. It's a decimal number of times. So cosine of 600 in the exact same instructions. And this was number 10, cosine of 600. We want a reference angle, and then we want the exact value. So this number is not very big. I can go ahead and subtract 360. It's only going to come out once, and then I'm going to have something that's between 0 and 360. So 240. That is not my reference angle. That is a coterminal angle. All I did is I subtracted one full loop around the plane because those full loops don't change our trig values. So what this is saying is I went one full loop around and then I stopped at 240. So in order to find a reference angle for 240, we need to know what quadrant it's in. So remember, each of these is 90, so there's 90, 180. All the way to the next one would be 270. And we're not going all the way to 270, we're stopping here at 240. So it's somewhere in quadrant 3. The reference angle is the distance to the closest piece of the x-axis. And since we're in quadrant 3, the closest piece of the x-axis is the negative x-axis, which is 180, and the reference angle is the distance between them. So 240 minus 180, which is 60 degrees. So our reference angle is 60 degrees. And then for the exact function value, if you look on your unit circle, or even if you just remember how to create that table. We had 60 degrees marked up here earlier. Remember, here was 60, and there's the points on the unit circle. But an extra thing that we need to remember, so cosine's the first one, so we know we're going to use a half. But what you also need to remember is when we're working in quadrant 3, cosine's going to be negative. And the way that I know that is because cosine uses the adjacent side, which is here, and the hypotenuse. Now your hypotenuse is always going to be positive, but if you're going to the left of the origin, that's going to be a negative. And when you create a fraction out of them, it's going to be negative. Now, there's a little trick to remember which quadrant has positive values and negative values. And it uses the little acronym ASTC. excuse me, that's, yeah, ASTC. And what this stands for is all students take calculus. So that's another way to remember it. All students take calculus. Whether you believe it or not, it might not be true, but it's just a little saying to help you remember what is positive. Now, if you look at the first letter for each of those words, in quadrant 1, everything is positive. In quadrant 2, sine is positive. In quadrant 3, tangent's positive. In quadrant 4, cosine is positive. So our angle, 240, was in quadrant 3. And in quadrant 3, only tangent and its reciprocal cotangent are going to come out positive. Everything else is going to come out negative. So we know that the cosine of 60 is a half. But since we're working in quadrant 3, we actually have to do negative cosine of 60. So negative 1/2. You also could just pull out your unit circle and go to 240 and see what that point is there. That point is going to be negative 1/2 negative radical 3/2. And the first one is the cosine value. So that one also says negative 1/2 from that way. And you'll see those are right. Reference angle was 60. Exact value was negative 1/2. Another one of the same type of question, but this one's a reciprocal function. So we're going to have to do something different to get that answer. So this one's number 11, and it's asking for cosecant of negative 240. It wants the reference angle and the exact function value. So anytime you have a negative angle, to find a coterminal angle, we're going to add 360. And we did that in the very first problem when we had negative 300. So negative 240 plus 360 is 120. So this angle goes clockwise around the plane and stops at 120. 120 is in quadrant 2. In quadrant 2, now we're being asked for cosecants. Cosecant is the flip of sine. So in quadrant 2, sine is positive. So flipping it is still going to make it positive. We just need to know what the sine value is at 120, and we're going to flip it. So 120 is not our reference angle. Remember, our reference angle is how far to the closest piece of the x-axis. So in quadrant 2, the closest piece of the x-axis is the negative x-axis, which is 180. And look and see how far apart they are. 180 minus 120 is 60. So another 60-degree reference angle. So what we're really doing here is 1 over the sine of 60, because cosecant is 1 over sine. The reference angle here is 60, and in quadrant 2, sine is positive. So on our unit circle, we had this one marked. We said that point would have a sine value of radical 3/2. And we're going to flip it. So think of it as 1 over radical 3/2. Instead of dividing by a fraction, we will flip and multiply. So 1 times 2 over radical 3 gives us 2 over radical 3. But I know MyLabs Plus is going to want you to rationalize that. So to rationalize, we multiply top and bottom by radical 3, and we get 2 radical 3 over 3. And we can check, and yep, 60-degree reference angle, 2 radical 3/3. I apologize, my kids are getting a little rowdy. They're ready for bed. But I'm going to try to finish this first. Hopefully they don't get too loud. Next one's still from homework number 2. It's number 13, and it's an application problem. It sounds kind of confusing, and the picture is also kind of confusing, but it's actually a really, really easy problem. So this is number 13, still from homework number 2. And I'm only going to copy part of that picture. Only part of that picture is important. If you look very closely, there is a little right triangle there. It says an airplane flies 100 kilometers from an airport in a direction of 240 degrees. Now, usually in real life, when people are using angles, they consider north to be 0, and they go clockwise, which is a little bit different than what we talk about on the unit circle. But if we understand quadrants and angles, it's not going to be that big of a difference, and especially reference angles, because we're going to use the reference angle there. It says how far west of the airport is the airplane then, and how far south. In navigation, directions are given in degrees measured clockwise from north. So we've gone 240 and 100 kilometers. The only thing I am going to copy is the triangle. Now, I'm going to put a little X and Y axes over here just so you can see the angle. So 240 is that outside angle. How far west the airplane has gone is the top side. How far south is the vertical side. And this hypotenuse is actually the 100 kilometers, even though the picture is labeled differently. And it's just because I think the picture is so small they couldn't get it slanted on the hypotenuse. So how far west is the adjacent side for our reference triangle, and how far south is the opposite side for our reference triangle. So what we need to do is just figure out what this angle is right here. And then we can ignore the whole 240 X's and Y's and souths and wests. So remember, every time you go a full quadrant, it's 90 degrees. So there's 90, there's 180. The rest of the way around is 270. The rest of the way around would be 270, but we've only gone 240, which means the difference there is 30. That angle is 30 degrees. And the way that this triangle is drawn, we know an angle, we know a hypotenuse, we want to solve for adjacent side and opposite side, and we're going to do them separately. So to work with the hypotenuse and the adjacent side, cosine uses adjacent over hypotenuse. So I'm going to say cosine of 30 is my adjacent side over my hypotenuse. And I'm going to solve for W by multiplying both sides by 100. And we can just type that in the calculator and ask the calculator what that side is. Now to do the opposite side, again, we know the hypotenuse and we want the opposite side. So we need to set up a trig equation that uses opposite and hypotenuse, and that is the sine function. Sine of 30 is opposite side over hypotenuse. So to solve for that south measurement, again, we have to multiply over the 100. So the west part is 100 cosine 30, and the south part is 100 sine 30. And they're two completely separate answers. We don't add them together or anything. And if you look back on the answer sheet, it asks for two answers. So the airplane is blank kilometers west, round to the nearest integer. And the airplane is blank kilometers south, round to the nearest integer. So all I have to do is I need to type these into my calculator. See what the calculator has to say about them. So 100 cosine of 30 is 86.6, but we're going to round it to the nearest whole number, so 87. And then 100 sine of 30 comes out to be exactly 50. So we've gone 87 kilometers west, and we've gone 50 kilometers south, technically. And those are just the other two sides of that triangle, where we need the hypotenuse and we can figure out the angle inside. And I'm sorry, my kids are in the kitchen right now. Give them just a second to leave.
Right there!
And if you look at the answers, 87 and 50, so perfect. The next one is number 20, and it labels some points on a unit circle. It says find two real numbers between negative 2 pi and positive 2 pi that determine each of the points on the unit circle given to the right. So if you have a filled out unit circle, which I posted on our Moodle page, you can find the positive one. To find the negative one, what you're doing is you're finding a coterminal angle. You're finding another way to get to that same spot, but just a different way to get there. So since they specifically say from negative 2 pi to positive 2 pi, I know my unit circle gives values between 0 and 2 pi. And to get negative values, I need to go clockwise around here. And the calculation that we could just easily do by hand to get coterminal angles in radians is add or subtract 2 pi, because 2 pi is the measurement in one full trip around the circle. So the first one, it says the true real numbers to determine m, and I'm going to try to copy this over to my sheet. I've got m and p there in quadrant 1. And this was problem number 20. And then there were two others, N and Q. N and Q. Now they have labeled 3 points, or at least marked 3 points in each quadrant, because we have 3 special angles in each quadrant. And those special angles are 30, 45, and 60 in degrees. We're asked for the radian equivalent. So on the unit circle, the one that's completely filled out on our Moodle page, I believe back in week 3, might be in 3 or 4, we want to know what the radian equivalent for this is. For 30, it says pi over 6. For 45, it says pi over 4. Over here on the negative x-axis is 180, and the radiant equivalent is pi. And then down here in quadrant 3, it's that third point in quadrant 3 is 240. And 240, let me see here, is 4 pi over 3. So that's one of the answers they want. They also want a negative answer. So to get your negative answer, what you need to do is you need to subtract 2 pi from each of these. So for m, one of the answers is pi over 6. The other answer is going to be pi over 6 minus 2 pi. Because what that's going to do is it's going to go clockwise around the circle and stop in the same spot. Now, if you're not good with fractions, you can do this in your calculator. You just leave the pi portion of it off and ask your calculator what 1/6 minus 2 is, and use math option 1 to change it back to a fraction, and then just throw the pi back on your answer. So on my calculator, a 6th minus 2, I get negative 1.833333 repeating, but I'm going to tell my calculator to change that back to a fraction, and it says negative 11 sixths, and we want to put our pi back on it. We left the pi off because if you hit the pi button on your calculator, it's going to throw in some crazy long decimal, and we don't want some crazy long decimal. We want exact values. So pi over 6 and negative 11 pi over 6 for m. Now p is at 45, which is pi over 4. So pi over 4 is one of the answers, and then pi over 4 minus 2 pi is the second answer. So again, we can do this in the calculator if we do a 4th minus 2, tell the calculator to change it back to a fraction and throw your pi back on it. So as a decimal, when I first type in 1/4 minus 2, I get negative 1.75. When I tell it to change back to a fraction, it says negative 7/4, and just throw your pi back on it. point N was at 180 degrees, and the radian equivalent is pi. The second one is going to be pi minus 2 pi. So think about how many pi's you have in each of these. This is just 1 pi, and this is 2 pi's. So 1 minus 2 is negative 1 pi's. We usually do not write coefficients of 1 though, but we do need to keep the negative. So negative pi is the other way we could write that. And our last one was Q. And if you match that up with the unit circle, it's 240 degrees. The unit circle also gives the radian equivalent, which is 4 pi over 3. So one of the answers is going to be 4 pi over 3 for Q. The other one is 4 pi over 3 minus 2 pi, which I'm going to type in the calculator as 4/3 minus 2, and then just change it back to a fraction. And it says negative 2/3, and then just throw your pi back on it. A lot of these questions, especially these last few questions, needed us to have information off that unit circle. So I strongly encourage you to print off a completed unit circle. Understand what the values on there mean, because you can answer a lot of questions with very little work on your test just from that unit circle. All right, so that was number 20. And I've got just one more here that I was asked about. It says find the complement and the supplement of the given angle, pi over 5. Complement and supplement for pi over 5. And that was 22. So most of the trig definitions I remember them in degree form. And then anything you say with degrees in it, the same exact thing applies if you change that degree measure to a radian. So complementary angles, they add up to 90. 90 in radians is pi over 2. So in radians, complementary angles are going to add up to pi over 2. Supplementary angles add up to 180. 180 degrees is equivalent to pi radians. So two angles in radians are supplementary if they add up to pi. So we're trying to figure out what angle is complementary and supplementary to pi over 5. So for the complementary, pi over 5 plus some other angle is going to equal pi over 2. And that other angle is its complement, or the complementary angle. So to solve for what that is, we need to subtract the pi over 5 over to the other side. And just like we did in the last problem, we can do this in the calculator. Just leave the pi's off because we want an exact answer. So that first one is 1/2 of a pi, and that second one is 1/5 of a pi. So we're just going to do 1/2 minus 1/5 in the calculator and tell our calculator to change it back to a fraction, and it says it's 3/10, and we just throw our pi back on. So for the complementary, it's 3/10 pi. For the supplementary, it's a very similar equation. The only difference is we want them to add up to pi. So for supplementary, pi over 5 plus something, its supplementary angle is going to give us pi. So to solve for what that is, again, minus your pi over 5 to the other side, and we can type that in the calculator as 1 pi minus 1/5 pi. We leave the pi's off though, and we'll just attach it to our answer. So 1 minus 1/5 is 4/5, and you just throw your pi back on it. And that was number 22 on homework number 2. I am going to post the notes that I just took and this video on our Moodle page so you can reference back to it. If you have some of your own questions that you want me to answer, I can do this again Sunday night and Monday night. I know our test is not due till Thursday. I might wait though. If several people send me in questions, I might wait and do them all in one video. That way there's not 12 different videos for people to look at. But if this was helpful and you realize you have some of your own questions that you need answered, just go ahead and email them to me, whether they are concept questions, and you keep seeing a certain word that you don't understand that you want me to discuss, or if it's a problem from the homework. I will tell you all of the test questions come from your homework. So it's very important that you understand those homework problems. You have to actually understand them. If you had to use the question help every single time to tell it, to walk you through it, and then you just kind of followed their pattern to do it and plug the number in, but you don't really understand what you did, you're going to run into a lot of trouble on the test because there's no help me solve it button. And you're going to have to remember how to do all that stuff on your own. So it's really important that you understand these questions. So if you have any more, if anybody has any more, go ahead and email them to me. I'd be happy to make another video if there are more problems. This set of problems didn't include anything from homework 3, which was section 5 and section 6. So now that we just finished that, some of you guys might have questions from that. And I hope y'all have a good night and study, study, study. You can get back into your old homework problems. If you, let me go out of here, sorry. You can get back into your old homework problems by clicking on the homework from your grade book. So if you go into MindLabs Plus, click on the grade book and then click on the homework. Now it's not going to let you change your grade, but it will at least let you go back in and see all the questions and also let you try them again, but it's not going to change your grade. So if you did not take notes while doing your homework the first time around, you might want to go back through some of those problems and take notes on how you did them. When you see that problem again on the test, you'll have some nice written out instructions on exactly how to do those problems. So I hope y'all have a good night. And I will be happy to make another one. Just email me and let me know if this is helpful or not.